Okay, Bismillahirrahmanirrahim. Assalamualaikum. Now it's pukul 2.07, 22nd of November 2020. Basically, this morning I have what we call it. I have given the tutorial question for you to do on your own, and I hope that you have tried to solve some of the questions. How many of you managed to answer at least one? How many? None.
Sir,
Yes.
nombor 3 dengan 4 tu susah. Nombor
At
1
least
tu
one,
tak faham sangat.
Nombor 1 boleh?
1 macam 50-50 je.
50-50, okay. Nanti saya bagi solution, lepas tu you buat lagi lah. Siapa angkat tangan tu? Ali Ihsan. Ali Ihsan, ada masalah apa? Ali Ihsan angkat tangan, ada nak tanya apa?
Bukan tanya, sir, bukan tanya. Silap.
Silap tekan Okay.
Sorry, sir.
Okay. Saya tunjuklah basic solution. Tapi tak semuanya betul You kena apa ni orang kata check balik lah. Okay. Do you see the slides?
Yes, sir.
Yes.
Okay. This one is actually the question from the example in the textbook. Okay. I think this one we have gone through the what do you call it, the same question that we went through the lecture, right? Or not? Forget. Okay. Consider that you have a 0.5 Hertz periodic square wave, x of t, which is okay, x of t is this one, okay, square wave, with a DC value of 0.5. So basically that's DC value of 0.5 and base to peak value of 0 to 1, where for one period x of t is given by this 1 from 0 to t, between t to 0 to 1. So basically this the value is 1 from 0 to 1 second and 0 from 1 to 2 second. So this is the x of t. So to filter out frequency other than 0.5 Hertz, convolve x of t with a signal made of single cycle of 0.5 Hertz sinusoid. So basically this is the one. So you have to convolve between this signal and this signal. So what is the convolution formula? The integration from minus infinity to infinity of x of tau and h t minus tau d tau, right? This is the general formula. Okay. Okay. Yep. Basically, it's either this or minus infinity to infinity of h of tau x t minus tau d tau. So both will give you the same answer. It's either this one is moving or this one is moving. Right? In the solution, they use this one. Right? So I'm going to stick to this solution. Okay. So if you draw x of t and h of t in the same graph, so x of t is given by the the black line, and h of t is given by this one. Okay. So y of t, the convolution, is given by this formula, which is this. Use the top one instead of this one. Actually, it will give you the same answer. Right? So if it's like this, basically what it means is that the one that is moving is the
Square
x of
wave.
t is moving. The square wave is. So you want to know which one is moving, which one is not, you look at this part. Right? So in this case, the square wave is moving. And for this example, the question is asked you to calculate from what do you call it, for t is equal to 0, 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, and 2. So you have to do calculation of the convolution for that. So first we'll take for 0. For t equal to 0, so you set up the the integration. Basically that at t equal to 0, the curve looks like this. So this is the square wave, and this is the sine wave. Right? So at t equal to 0, so h tau x t minus tau d tau is, you can write as h tau x 0 minus tau d tau. So this will give you which part? Basically that x 0 minus tau is equal to actually this one, this part, this part. Okay. So what is this part is 1. This is equal to 1. Equal to 1. So basically this integration from 1 to 2, this part. Because this is the one that is non-zero, right? And this part is 0. So basically the integration is from 1 to 2 of sine pi t dt. So sine pi tau d tau lah, because this we use this one, right? So this, if you do the integration, you will get minus 2 over tau. So basically that this area is minus 2 over tau. The minus is because of the below the 0 line. Okay. This is for t equal to 0. Then when t equal to 0.25, so basically that it's shifted by 0.25, then this is the equation. So from the graph, you see that it's actually non-zero here and non-zero here, this part. So you can see the first one is from 0 to 2.5, because it's moving up to 0.25 here. So this is the integration. And the second one is from 1.25 to 2. So this part is for the first integration, this for second. So this First one is the second one. So you do this integration, so you get that answer, minus square root of 2 over pi. So basically this is the area. So still minus sign because this area is bigger than that. So the resultant is that actually still the negative sign. Right? Clear? And you do this for all of them. For 0.5, basically that the square wave move 0.5 to the right. So integration is from 0 to 0.5. This is this part. And from 1.5 to 2 for this part. So since basically this is positive area, this is negative area, so it cancels out 0. Okay. And for t equal to 0.5, so it shifted 0.75 second. So this is actually from 0 to 0.75. A here, this is B. Yeah. A area, this is B area. Yeah. So this one is from 1.75 to 2. Right? So this area. Right? So the answer is pi, square root 2 over pi. So of course this is positive because this is bigger than this area. So the resultant area is positive. So you need to do the integration. So the same thing when t equal to 1. So when it shifted to 1, so only this one is what we call it overlapping with 1, and this one is overlapping with 0. So you don't calculate that one. So the integration is from 0 to 1, from 0 to 1, right, of this. So you get 2 over pi. Okay, for this one, t equal to what we call it 1.25. So this area and this area from 0.25 and 1.25. So you get pi over 2, square root 2 over pi, right? And same thing with this one, this equal to 0, right? So you just do the integration, and this is minus square root 2 over pi. Clear? So basically that this is just to show you the concept of what we call it convolution, which signal is moving, which signal is stationary. So just show you at certain intervals so that you do the calculation so that you understand. So this is for the at t equal to 2. So basically that only this part which is you have 1 multiplied by the sign. So it's a non-zero, whereas this one is that sign multiplied by 0 is 0. So this is your integration, right? Okay. For this one basically that remember the question, the tutorial one that I asked you to prove that y of t is equal to ut convolve with ut result in the what we call it r of t, something similar, right? So this one is basically that you have you need to find the y of t where x of t convolve with a shifted unit step function, a delayed unit step function. So if you have this, therefore you can write your convolution is this. Integration from minus infinity to infinity f of x of tau u t minus t naught minus tau, right? Okay, d tau. But ut minus t naught minus tau is equal tau greater than t minus t naught. Therefore, you can set the integration yt is equal to minus infinity to t minus t naught for x tau d tau. Okay, so this is basically minus infinity to t of x tau minus t naught d tau. Okay, so this convolution results by interpreted as the output of the integrator. So basically, this is the integrator. Okay? So this integrator is basically that is the what do you call it? This integrator, this, and followed by the delay. So this is the delay. Okay, or you delay first, then this is the integrator. Okay. Yes.
Macam mana nak tahu yang ut minus t naught minus tau tu sama dengan kosong, sir?
Okay. This is
Mini step.
ut, right?
Ah,
0. And this is
delay.
t naught. This is ut
T minus t naught.
t naught, right?
Yes, sir.
Right? Okay.
Betul, sir.
So if tau equal to t minus t naught, t equal to
Negative tau minus t naught.
t is equal to tau plus t naught lah.
Ah. Ah.
So how do you set up this?
Pasti lah, sir. Cuma
Tak pasti. So macam mana?
Gantikan je sir dalam T tu. So, gantikan
Macam
T
mana?
tu sir. T equal to tau plus T naught tu ganti dalam T minus T naught minus tau tu. Jadi kosong lah.
Jadi kosong. Dia basically this one. Bila you nak buat integrate tu, misalnya you letak dekat tau and this is 0. So basically this actually t minus t naught. Because you inverse this one. This you inverse. You want to do what call it the convolution. So basically that you convolve this with this. If this is like this lah. If let's say you have ut convolve with u t minus t naught. Okay. So basically that you convolve this with that. Remember the one that we did previously?
yang mana tu?
Mana? Yang
Shifter
yt is equal to ut convolve with ut. So what we did was basically that One is this one at 0. This is ut. Then another one that this is actually u uh, uh, u minus tau. Remember?
Yeah.
So basically it's the same thing. This is actually is similar. So if one, this is happen this way is at 0 because there's no delay. If there is a delay, if you convert between ut, convert with u minus tau minus t naught. So ut minus t naught is like that. Then after that, when you inverse, so it becomes like this.
Okay.
Okay. So in this case, let's say you have xt minus ut naught. So let's say xt you have, this is xt. This is your t. Okay. And this is actually, if you plot on the tau, so this is x tau, this on tau. Okay. You want to compare with this. So basically that this one, you flip like this. So that's why we say that tau is greater than t minus t naught. So because t minus t naught is here, so greater than this is 0. So your convolution is basically on the part. So when you superimpose, get something like superimpose with that, so the convolution is somewhere there. Because this part is 0. So that's why it become integration non-zero is from minus infinity to t minus t naught. Okay?
Okay, yeah, faham.
So that is the reason why you have this, because you flip, you inverse of this u t minus t naught inverse.
Okay, so okay.
Okay. So we try to do. So this one, actually, I'm trying to give you to do on your own, to do the convolution of something like this. T plus a delay of t1 convolve with u t of delay of minus t naught. One delay, one advance, where t1 is greater than t naught. So maybe t1, maybe the magnitude of t1 maybe, let's say, were 1. So jadilah u t plus 2 convolve with u t minus 1. So try to do this. Right? Try to do this example on your own. So basically that you have one is yes, is t minus 1. Let's say this is u t minus 1. Okay. And another one you have, this is u t
Plus 2.
plus 2. Okay. And above the other one maybe then let's say you flip this one. Let's say you want to write basically the integration, basically the integration of u t minus 1 with let's say say I want to use, let's say y of t is equal to the integration of minus infinity to infinity of u tau and u t minus tau d tau. Let's say this one is, you take the um, u minus t. Let's say this one you take the u. Tau is tau here is t minus 2. One is u. You take this t minus this one is t minus tau. Is which one? What is tau? T minus tau minus 1 ke? D tau. Cuba cari ni. Cuba you check. So basically that you want to do this, but in terms of the what do you call it graphical, basically you flip. In this case, if this is the equation, I flip this one. I flip this one. I flip this one. So it becomes like here, somewhere here. So this is when you flip here, then basically that this actually will this one will move here. So what do you call it? The area here. Okay. So you check this one. Later, one I'll give the solution next week. I want you to try this. Try this one. Try this. Try to do this part. This one.
All right, sir.
This is
Alright.
important.
Okay, sir.
This is important. Oh my god. Oh my god. Important, huh? Okay.
Convolution basically that you need to what do you call it be able to do the graphical in the to show it graphically and also mathematically. Maybe you need to study on the convolution is on the convolution of two unit step function delay delay unit step function. Basically this you have two delay unit step function to do, or another one maybe the what do you call it the convolution between a square wave with maybe rectangular, maybe a triangular wave. So this kind of example you need to be able to do for convolution. Spend more time on this. So that's why I don't give you the solution for this, because I want you to try on your own. So next week I'll give you the solution.
Right.
And for the example, maybe you try this one. By put numbers on T1 and T2. Let's say you just pick T1 as 2 and T0 as 1. Right?
Okay.
This is also convolution problem. What does it mean by unique impulse response? What it means? Then you have the signal. You have the system. See. It means a unique impulse response is basically that, and in here is h of t. Okay, so y of t is basically x of t involved with h of t. So unit impulse response is clear that the input is clearly delta t. So this is x of t. So the input is you have an impulse. Go through the signal. So an impulse delta t convolved with h t, you get out the y of t. Y of t is actually equal to the convolution of delta t with the h of t. So this is actually what happened. What is the convolution of this function? What happened?
Convolution
This
of this function.
this is the
Oh,
any function convolved with a
ini
impulse.
impulse
The result is the
input.
result.
Oh,
Yes. So in this case, the input is the impulse. So what is the result of this? So
impulse
get out h of t,
h of t.
because this is not impulse.
Oh,
So what is h of t? Is the example. This is the h of t. But the output, it says that the output of this system give you this when you compare with this. So therefore h of t is this. So now you know what is h of t. So h of t is actually equal to delta t minus e to the minus t ut. So this is h of t. So now the question is that it says if the input is this, what is the y of t? So now for A, what it says is that if x of t now is equal to u of t minus u of t minus 1, minus 1, convolved with h of t equal to delta t minus e minus t ut. So what is y of t? That is the question for. So for B, basically that for this, you change this to this. So convolved with h of t. For C, this is x. This is x or d. Fine. Therefore, so what I explained just now, basically, if the input is delta t and the output you give this, so this is the output h of t. And if you convolve, if u of t, if the step function, okay, convolve h of t is the system with this one, so you get e minus ut minus t of from the, we call it um, what the okay. Let's say if this is the input, ut minus u minus 1, go through the system of this. What is the output? T here is y. So basically that you have integration of ut minus ut minus 1 convolve with h of t. This is actually convolution of ut h of t et minus convolution of ut minus 1 h of t. If the convolution of u of t h of t is called is this based on this calculation, therefore if you have a shifted a delayed one, so it's also a delayed. You delay t minus 1. Okay. So basically that this one is so you can use this formula. This calculate for this. So you get for t less than 0, it's 0, right? So you get this. You try to get this. Boleh buat ke?
InsyaAllah saya.
Basically that you need to know the integration.
Betul.
And also you need to know the property. If you have delay this, so the answer also delay of minus 1.
Kalau kita delay, dia ada minus 1.
This dia punya result pun delay minus 1 ni. Yeah.
Oh, okay. Alright.
So instead you see this, if input is delayed, so the output is also delayed.
Yes. Yeah.
And for t ut, so the integration of this, what is so basically that this one is the integration of t ut then h of t dt. So you just actually that you need to set up this by changing the according to the input. This actually you have to go through the what we call it tables, right? The properties of the convolution. You have to understand the properties of the convolution. This is a ramp. TUT ramp. TUT is
T minus.
So input ramp go through the system of this system. What is the output? Convolution. So this is the result. So basically that the output is actually start from 0. Because before before t equal to 0 is the value is 0. Cancel out. Right? And C, you take this and convolve with this. And you get this is the answer. Okay? And D is this the input and convolve with H. Okay? You get this answer. Okay? So you need to try on your own, right? So that you understand. But the most important is that you try to, kalau yang lain tak boleh buat, make sure that you can do this example. Make sure you be able to do this. Right?
Yes, sir. Okay. InsyaAllah.
Yang lain ni susah ni semua ni, but just for you to get used to something easy, what do you call it, difficult, so that you can do the easy ones.
Oh, so test 1 ni 20% kan?
Saya pun tak ingat lah.
Alamak.
Ya kot.
Okay, sir.
30% ada quiz 10% ke? And
Quiz.
10% is the assignment. Ada assignment kot. This one is the Fourier series, trigonometry. Basically, let's say you have a square wave with a peak-to-peak voltage spanning of -1 to 1 volt DC, and there's a 50% duty cycle. This is the 50% duty cycle. Use the time origin so that the series contain cosine terms only and B sine terms only. So for cosine terms, basically that it has to be what kind of function?
Even.
Even.
Sine, odd.
Odd.
So this is the even function. Okay? This is the odd function. So you shift this square wave to make it even. So this is what you get, and this one you shift to make it odd. This is what you get. Okay? So since you already have the even function for A, then this is the solution. You set up the x of t is equal to summation of an cosine n omega t, where omega is equal to pi over t, where t is 10 millisecond.
Milli.
Yeah.
2
So,
over T.
2 pi over t. So because the question is that it says here t is basically that because 1 kilohertz is 1 kilohertz. So basically if you have a 1 kilohertz square wave, so the t is equal to 1 over f, right? So equal to 1
over
millisecond.
Yeah.
Yeah. So that's why t is 1 millisecond because of 1 over f, 1 over 1 kilohertz. Okay.
Okay.
So from here, you can find the an, but the bn term is equal to 0 because this is the even function.
Yes.
Okay. So this is the formula for the an. You do the integration from minus t over 2 to t over 2. Basically minus t over 2. This is t over 2. Okay. So the integration is from there because this part is 0 and this part also 0. 50% duty cycle. When you do the integration, you get this. So if you expand it, so you get this is the first term, second term for your trigonometric Fourier series for given function. And this is when you shift it to odd function. So basically that this is your from 0 to 1 millisecond, and your integration is basically from 0 to t over 2. 0 to over 2. Because t is here. So a terms is equal to 0 because this is a function, right? So you only have a bn term. So you do this. This is the bn terms. And if you substitute n, 1, 2, 3, 4, then you get this this first function, second, third, fourth, fifth. Because for n, for the given if n, what call it, sign is equal to 0. That's why you have 1, 3, 5, 7, 9, 11, 13, 19, 21, so on. Okay. This is Fourier series also. Let's say you have x of t is given by this function. Okay. And you want to shift to make this to only contain an or contain bn only. So how are you going to do this? So let's assume that the shifted function is called y of t, and you shift by t naught. Assume that you want to shift by t naught. Okay, is by t naught second. So your function, your new function, your shifted function will be a sine omega naught t minus omega naught t naught. Okay? But this is basically what you write is that a sine omega naught, and you shift by t naught, so therefore omega naught times t minus t naught plus b sine b sine omega naught t minus t naught minus theta, because you shift by the new function is actually you shift by t naught. So actually you get this lah when you expand this omega naught t minus omega naught t naught, and this part is omega naught t minus omega naught t naught minus theta. That. So now you substitute this alpha and this term as this. So therefore, this function you can write as this: a sine omega naught t minus alpha plus b sine omega naught t minus beta. Clear? Just substitution. Okay.
Substitution, yes. Okay.
So now you get, so this actually can be written in this form. This part actually can be written as this. This part can be written as. So therefore, you can rearrange the equation. So you get sine omega naught t, b plus that, and cosine omega naught t. So basically, why do you do this? Because you want to this in this format. So this is the what I call it, to make AN, this is the BN. So from here, so this is actually, this term is actually AN. Nah, this is BN. This is the BN. This is AN. So if the series is only to contain AN, so that this term will be equal to, so why we have A sine alpha plus B cosine beta is equal to 0. So from here, then you can write in terms of this, just a method of using your trigonometry. So this term will be 0. So from here, then you can find what is A, what is whatever. So for the part B, if you want to have only Bn only, and this term is An, it's also A sine alpha plus B sine beta is equal to 0. So therefore, tangent alpha is equal to 0, and T naught is equal to 1 over omega naught tangent minus 1. This, because the question is asking you determine the T naught to be omega naught. Oh, so that is the it's difficult, but it actually show you how you can what do you call it, manipulate function to make it equal and odd by using the thing and use the trigonometric property. The Fourier series. This is the last one. This one you need to find the Fourier coefficient, exponential Fourier coefficient of periodic rectangular waveform with a period of t equal to 1 millisecond to pick of plus minus 1 volt for the following path with actually tau value is given. So for a exponential Fourier series is written in this form. X of t is equal to the summation of minus infinity to infinity x of n e j n omega naught t, where xn is equal to 1 over t integration over the period t xt e to the minus j 2 pi n t over t dt. And you have this signal, right? This rectangular signal from minus 1 to 1. And the path width is tau and the period is t. Right? And this is actually, if you do the integration, so you get this as the function of xn, the coefficient. This is actually the coefficient of the exponential Fourier series. And if you calculate this, then you get all this. This actually, I calculate, this is actually tau over t. For the first one, this is actually the value of tau over t. So you can double check so that you can, what do you call it, substitute here when you do calculation. So for n equal to 0, so x of n is 0 for the first function. This is actually the a, b, c, d, e is here for this function. And this is actually the coefficient from n to 0, from 0 to n to equal to 6. Right? So you can check this. This is actually the solution given, and you can check from your workings. Because what you need to do is actually you have to set up this, basically this equation, right? This. So x of t is basically this x of t. Okay, any question? Any question?
Sir, test masuk sampai mana sir? Analog filter ke sir?
Analog filter tak masuk kot. Tak masuk.
Tak masuk ah. Dia sampai mana sir? Ada scope tak? Ya, scope 2.
Ada scope.
Ada scope ah.
So basically the scope is I contain here
Okay.
one basically signal operation,
Signal operation, okay.
and
Convolution.
Fourier series and
Transform.
but
Laplace.
and frequency response. Body.
Both plot, okay.
So basically the test will be in this.
Alright sir, thank you sir.
So signal operation is quite easy. Basically, that most probably that you need to do give you some function, for example, maybe y of t to beta t plus u of t minus u of t minus 1 r of t minus 2. Yeah, that convolution we have covered today. Fourier series, most probably that we give you the maybe only one, and find the coefficient. Most probably like that. Okay.
Inshallah.
Laplace, I don't know yet because this is we'll do the question for plus. Other lecturer, this another lecturer, this another lecturer. So my part is this part, Laplace.
Oh, sebenarnya Laplace ah. Okay.
Dia tengah fikir soalan macam mana nak buat.
Oh, tak siap lagi soalan sir.
Saya
Oh.
tak memang lagi.
Sir, test kita bila Test kita bila sir?
Test hari Jumaat bulan 12.
Hari Jumaat bulan 12.
Berapa bulan dah. Oh. Okey.
Banyak.
Sekejap saya cek Saya cek sekejap. Bila?
12 ke sir? 11 bulan 12 ke sir?
Yang saya bagi hari tu bila
Sir ada bagi.
Sebenarnya saya ada bagi hari tu.
Wah, nani gasta.
Ya.
Okay.
Saya cari dulu kat mana dah. Kejap. Kita cari dalam dalam yang ini di dalam saya punya WhatsApp. Itu penting lagi ni. Saya malam ni pun ada kelas lagi ni.
Kelas apa sir?
Capstone.
Oh.
Untuk apa ni student nak itu. Okey, 11 Disember.
Okay, sir.
11 Disember.
Okey, soalan
Petang ke malam?
Pukul apa, sir?
Pukul apa?
pukul berapa? Pukul berapa? Pukul 8 hingga 11 pagi.
Pagi.
Jumaat.
Sebelah. 8, 3 jam sir?
8 hingga 10.
Oh, okay.
8 hingga 10. Waktu kelas.
Oh,
Hari Jumaat.
Okay, sir.
alright sir.
Okay, so basically that itulah apa ni yang akan apa ni signal operation. Okay. Signal operation dengan convolution dan dia dalam satu soalan. Ya. Satu soalan. Fourier series, Fourier transform satu soalan. Frequency response and body plot satu soalan. 4 soalan semua. So basically it's 2 jam because we expect half an hour is enough for one question.
Half hour, one question. Okay.
Soalan saya, kalau saya buat, you faham dalam 10 minit boleh siap. Kalau tak faham,
Tapi tutorial
Ya.
sir buat ni pun payah nak faham juga ni sir. Macam mana?
saya nak faham.
Oh, dia macam macam tu sikit lah.
Macam mana?
Sir, saya nak tanya sir, yang tadi property sir bagi tu kan?
Ha?
Kiranya kalau kita jumpa input dia macam di unit impulse T, ya output dia memang kita kena letak yang unit impulse T, eksponen, apa semua tu memang kita tak payah nak kira, memang macam tu je dia. Betul sir?
Ya, dia basically itu dah shortcut. Kena ada jalan kira lah.
Alamak.
Ada jalan kira.
Macam mana?
Sir, 2 jam tu termasuk masa hantar sir.
Tengoklah dulu macam mana saya nak buat.
Okay, sir.
You apa ni? You hantar kat saya.
Oh.
Bukan kat depan. Nanti hantar untuk yang student saya. Tengoklah. Adalah apa ni macam 10 minit extra ke untuk nak apa ni gambar, post apa. Dan cuma waktu test tu is 8 hingga 10. 8 pagi hingga 10. So kalau saya biasanya saya akan release soalan 5 minit awal daripada pukul 8 tu. 7.55 tu dah boleh download soalan lah. And after that upload dalam 10 minit, 15 minit lah. Untuk maknanya dalam 10 suku tu kena up lah. Kena masuk dalam MST. Ada masalah untuk MST dan melalui email lah. So, okay. Any other question?
Nanti ada talian hayat tak sir waktu test?
Tapi ayat macam mana tu?
Clue-clue lah sir, tak ada?
Tak ada lah. Formula kita bagi.
Oh, okay.
Formula bagi lepas tu is open book.
Open book? Oi, serius lah, alhamdulillah.
Rasanya lah open book lah. Apa ni? Kalau kita tak bagi open book, open notes pun you buka juga. Bukan kita nampak pun.
Astaghfirullahaladzim.
So might as well kita bagi open book, open notes. might as well kita buat legal terus instead of benda tu illegal.
Betul so, betul.
Saya punya apa ni kata, saya punya polisi mudah aje. Kalau benda tu kita tak boleh nak kontrol, kita
Kalau kali itu kita layan. Okey sir.
Cuma soalan tu kita buat susahlah sikit.
Itu lah tu.
Pandai-pandailah kita buat soalan untuk supaya you buka pun, you meniru ke, you discuss pun, you tak boleh nak jawab.
Itu fashion lah sir.
Auto-fail.
Kalau kami.
Saya punya soalan memang macam tu. Kalau saya buat soalan, apa ni, kalau open book, open notes sebenarnya, you memang kena kefahaman. Kalau you tak faham, memang tak boleh nak jawab. Tanya orang lain pun tak faham.
Kena tanya Tuhan lah. Susah.
Tanya Tuhan lah. So basically that lah. Rasanya apa ni I basically daripada dulu lagi I open book, open notes saya suka. Because how I learn dekat universiti dulu pun I suka test yang open book, open notes. Or take home exam pun. Yang exam 24 hours. So that's why kalau kita boleh okay, saya lah. Okay, so basically that itulah alam biasanya kalau saya buat apa ni open book, open notes lah. Kita tak nak control pun. Whether you meniru ke tak apa semua, so might as well kita bagi chance for you to use your notes, use your textbook. Bila jawapan tu kadang-kadang kita pun tak boleh juga nak check whether you discuss among yourself or not. So kita check tahu basically whether you discuss ke tak. Bila datang jawapan tu sama je, buat mistake sama je, kita tahu lah ni masing-masing discuss lah ni.
Tu senior saya lepas tu, kami baiknya.
Ada yang yang final exam last semester semua ambil pada website semua je, kena tolak markah lah. Dengan saya. Because bila dia submit tu, okay, I baca ayat tu lah. Saya ambil ayat tu, saya copy ayat tu, saya masukkan dalam Google. Apalah website mana yang dia ambil. So, kalau 2-3 orang hantar ayat sama je daripada website sama je, dan saya tahulah main copy and paste je masing-masing. But kalau open book, open notes ni, you can go to any website semua, ambil information apa semua, tapi make sure that you
paraphrase.
Kata you do paraphrasing. Kalau you nak ambil buta-buta macam tu, kalau you kata okay, rujukan this website, I accept. But the important thing is that the ethics, the honesty of bila you ambil. Bila open book, open notes, kalau you ambil daripada website, then you have to okay, it's from this website. Itu cara saya. Cara orang lain saya tak tahu. Terus cara saya, you have to be honest. Kalau you ambil daripada somewhere which is legal because it's open book, open notes, that you can browse mana-mana website untuk dapatkan information. Kalau you ambil bulat-bulat, you tell us. Okay, ambil kat mana? Kalau kita cari, tiba-tiba jumpa and you tak cakap ambil kat mana, kita consider as you are dishonest.
Okay.
So kita tolaklah markah. Because tak ada reference, you tak refer, you tak bagi kredit dekat mana you ambil.
Okay,
Saya is an engineer. Engineer basically that one of the ethics of an engineer is that he must have the integrity. He must have the honesty. Kalau dia ambil somewhere, dia cakap dia ambil somewhere. Kalau dia ambil somewhere, dia faham, lepas tu dia olah balik kepada ayat kefahaman dia. Dia tak payah dah kata okay, I ambil dekat sini. That one is okay. Tapi kalau kita ambil bulat-bulat daripada website lain apa semua, lepas tu kita tak bagi kredit dekat dia, that is considered as unethical. So saya latih pelajar saya supaya to be ethical. Because kalaulah you pergi, bila you dah grad nanti, you akan register dengan Board of Engineers. Lepas you register, kalau you nak jadi engineer, you kena register dengan Board of Engineers as graduate engineer. Then you belajar, you kerja sebagai engineer selama 3 tahun. You dapat experience dalam engineering, sama ada you kerja bawah IR ke ataupun you tak kerja bawah IR ke. Tapi bila you nak ambil professional engineer, you akan, apa yang you buat tu, pengalaman yang you ada tu, professional engineer nak kena endorse. Dia kata okay, this memang you punya pengalaman. So kalau you punya report, you tulis apa yang you tak buat sebenarnya tapi you kata you buat, that is being unethical. So ada juga yang gagal because of that. Because dia tulis report yang mana bukan dia buat. So that is considered as unethical. Walaupun dia dah ada experience, memang sepatutnya dia dah boleh dapat. Tapi because of that, ada yang digagalkan. Sekarang ni saya jadi mentor untuk 4 orang ada komander dalam kapal TLDM, dan saya 2 kapten kapal yang bawah saya untuk nak dapatkan IR. So sekarang ni saya kena kejar dia orang untuk report lah, nak tengok, so that saya boleh komen apa semua, so that they can go for exam and interview untuk dapat IR. So that's why the ethics and integrity tu penting dalam engineering.
Baik, sir.
Okay, next. So rasa sekarang dah 3.20, so nanti saya akan forward the solution yang saya bagi tadi tu, and you cuba go through and study balik, tengok boleh tak dapat apa sebagaimana yang dalam solution tu.
Baik, sir.
Okay. So and lepas tu you submit kat I lah apa yang you buat.
Okay, sir. Sebelum bila sir? Submit dekat team ke sir?
Submit dekat team ataupun email lah, jangan WhatsApp. WhatsApp kadang-kadang saya punya crash hilang lah.
Oh, okay.
So benda ni basically bukan apa, saya suruh submit ni basically suruh you buat. Dan satu lagi pun, bila dekat the final mark nanti, kalau ada yang borderline apa semua tu, that one saya make consideration untuk naikkan lah.
Maka kesian sir.
Okay. Saya akan buat macam tu. Okay. So sekarang dah 3.21, so dah 1 jam lebih. Okay lah, thank you. And kalau ada apa-apa, mesej saya nantilah. Tapi cuba dulu buat, tengok apa yang ikut yang solution saya bagi tu, tengok dapat ke tak. Okay, thank you.
Alright, thank you.
Okay, Assalamualaikum. Bye.
Jaga diri.